So problem 78 is a sister to your assigned problem 79, and I've traced both problems give you a graph that they want you to work for, and I've traced that here. And again, what this problem wants you to do is write down an equation for this polynomial. It's very similar to the previous problem we did, problem 52, where you're given 3 zeros at another point, and you're asked to find a polynomial that that cuts through all of those points. In this particular case, there's one other feature that gets involved, because the problem says write down the equation of a polynomial and write down that polynomial which has the smallest degree. Yeah. So if we look at this, we notice from the end behavior would indicate that this is an even polynomial, even degree polynomial, right? Because in both cases, as x goes to infinity and x goes to minus infinity, in both cases the function is going the same place, to minus infinity, and that's characteristic of even degrees, polynomials with degree 2 or 4 or 6 or 8. So we'll make sure that our answer is even when we give it. So what else can I pull off this graph? If you look closely, I believe that the points that they're indicating are zeros are the points -1, 0, 1, 0, and 4, 0. You'll just have to look at the text and read the graph yourself in order to verify that. And then they've given you a point, 3, 8, that this polynomial has to go through. As I said, there's one other feature, and that is that these zeros, 4 and 1, 0, in that case, the graph cuts through. It crosses the x-axis as it goes through the 0. In this case, -1 to 0, it touches. And we know that whether it touches or crosses is associated with the multiplicity of that 0. In this case, this will have multiplicity 2. The lowest multiplicity 2 could be 4, could be 6. This will have multiplicity 1, 1, 3, 5. But if we're going to get the lowest degree, then let's assume that the multiplicity is 1. And when we do that, then we can say that this function must be, I'm going to include the little scaling factor right there, x minus 1, or x plus 1, x minus 1, and x minus 4. And then I'm going to come back and fix the multiplicities, because I said these two have to have multiplicity 1. They do. This one needs to have multiplicity 2. So the last thing I want to do is to scale this thing properly. If I put 3 into this function, I get out a times, let's see, 3 plus 1 is 4, squared is 16, 3 minus 1 is 2, 3 minus 4 is -1, that's minus 32a, and I want it to be equal to 8. I think that says that a is equal to -1/4. And so the function that we're looking for is f of x is equal to -1/4 x plus 1 squared x minus 1 x minus 4.